Okay, in section 4.3, we're going to combine two concepts that we've seen previously. One is the idea of congruence that we've talked about with angles and line segments before. We can see this unpacked in a picture when we see these hash marks here. We know that side BC is congruent to side ST. Okay. Likewise, we also would be able to say that angle S with those two hash marks is congruent to angle B. So we want to be able to write what we would call a congruent statement, but we want to extend it to taking all of those parts and showing that two triangles are congruent. The other piece of this is our third angle theorem. We know that the angles in any triangle add up to 180 degrees. So as soon as I know that I have two angles in one triangle that are equal to two angles in another, then I know all three triangles are all three angles are equal in those two triangles. They have to be by subtracting the two angles that we have from 180 degrees. So what we want to do in these congruent statements is think about what are the parts that are congruent to each other, and then write a congruent statement. So I'm going to go through systematically and show you what I mean. I'll go right in alphabetical order here. I would start with angle A, right? And I can look at this and see that angle A with one hash mark on it is going to be congruent to angle J. Okay, so that's the first part of those two triangles that I'll have a congruent statement for. Then I can say angle B, we'll go again right in order, is going to be congruent to angle K. All right, and then finally we'll get to angle C, and we'll say that that is congruent to angle L. And you can see three hash marks here and three hash marks here. So now I'm going to extend this and just go with triangle A, B, C, and it's really important that the ordering is correct. So A matches up with J, so that's going to be triangle J, and B matches up with K, K, and L. So those two triangles are congruent. So now I can also do my segment congruence. So I have segment AB, first two letters, congruent to segment JK. Okay, and then we have segment BC, second two letters, congruent to segment KL. Just take them right in the same order that they appear. And then finally, we could also use segment AC, first and third letters, congruent to segment JL, first and last letters there. So I want to do this for each one of these triangles. I want to write the appropriate congruent statements. So in the next situation now, we have the triangles sort of joined together. So I'm still going to do the same thing. I'm going to go systematically here and start with angle A in the first triangle. So we have angle ABC in this first triangle. And let's observe that angle A in the first triangle, so we're talking about this angle here, is congruent to angle D in the second triangle. All right. Now for the next one, I want to be really careful here. We could be tempted to say angle B is congruent to angle B, which is true by the reflexive property. But notice the angle B that I'm talking about here. In triangle ABC, right, when I talk about triangle ABC and what triangle that would be congruent to, that's what I want to think of, the other triangle. Well, the other triangle has this angle C that has a congruent angle to it. So that's actually the angle we want, not angle B congruent to itself. Sometimes we would have it the other way. And then finally, we'll have angle C in that first triangle is congruent to angle B. Kind of seems redundant, but we need to be able to state it that way. So what we really have for the two triangles, we have triangle A to B to C. Oops, I already wrote that. Triangle ABC is congruent to the other triangle is going to have to be listed as DCB. So remember, when we're thinking of these two triangles, we're looking at ABC, but the triangle that it's congruent to is going to have to be, is going to go from D to C to B. Notice when we went from A to B, we went across these two tick marks. And when we go from D, we go across the two tick marks so that we're identifying the correct two triangles. Right? And then finally, the segments that would be congruent, we would have segment AB is congruent to segment DC. We have segment BC, and this is sort of a reflexive property type of situation, is congruent to segment CB. That's this one here. It's equal to itself. We just list them in a different order. And then finally, we would say segment AC is congruent to segment DB. Okay, so now in our next one, let's look at sides that are labeled and that are equal to each other. And remember, we have parallel lines here. So once I see that I have parallel lines, I'm going to want to label that alternate interior angles are equal to each other. Right? And then we'll also be able to make use of our third angle theorem. So I'm going to create the tick marks myself simply because I have parallel lines. When I have parallel lines cut by that transversal, then I know that those angles are congruent to each other. So the first angle I'm going to talk about is this angle K here that's in blue. So this is going to be angle K is congruent to angle M in the other triangle, those two blue angles. Then I'm going to go down to angle J by the third angle theorem. That's going to have to be congruent to angle L. Once I have two angles in one triangle equal to two angles in the other, then by the third angle theorem, those third angles would be equal. And then the other angle that I marked congruent would be angle, in this first triangle here, it would be angle M. When we think of K to J to M, angle M is going to be congruent to angle K. Right? And they're two different angles though, right? This is angle K in the first triangle, but angle K in the second triangle lives up here in the red. Right? So now when we list our segments, it'll go like this. Segment KJ is congruent to segment ML. Segment JM is congruent to segment LK. And then finally, segment KM is going to be congruent to itself, basically, but we'll list it as segment MK. So our two triangles, ultimately we want to get to here is triangle KJM, right? KJM, we're talking about this triangle, is going to be congruent to triangle MLK. M to L to K. And that's our final congruent statement for the two triangles. So now I want to try to do it a little bit differently. I want to just list the two triangles. So here, if I start with, we'll just pick whatever triangle we want to start with first. And in this case, I suppose I can go in alphabetical order. Just a routine I like to follow. So I start with triangle EFG is going to be congruent to, now let's think about what triangle that would be. E to F, we go from no mark to the 90-degree angle and across three tick marks. So in order to do that, that would have to be JK. J to K to G. So, or I'm sorry, JKL. Right, so when we have our triangle congruent statement, if we start off with that, E to F, G to G, I went 3 tick marks to 2 tick marks to 1, right? 3 tick marks to 2 tick marks to 1, J to K to L. Now we could easily list all of our congruent parts. Angle E would be congruent to angle J. Go in the opposite order. Angle F would be congruent to angle K. And angle G is congruent to angle L. And then we can do our segments, of course. Segment EF, first two letters, congruent to segment JK. Segment EF, or I'm sorry, let's do FG. Go in that order. Second two letters, congruent to segment KL. And then finally, segment EG, first and third, congruent to JL. And we have all 6 parts and the 2 triangles. So let's try to do the same here. Let's go, if we go in alphabetical order, let's start with triangle A, B, C. And let's think about what triangle that would be congruent to. If I start at A, 1 tick mark here right in the middle, we got to start at D. Then where did I go after that? From A, I went to B, which has 2 tick marks. So from D, I have to go to C, which has the 2 tick marks. And then finally, we'll end on B. It gets a little tricky when they share common vertices, right? And then therefore common sides. So now we can easily say that angle A has to be congruent to angle D, and we can see that in the picture. Angle B, not going to be congruent to itself because we're talking about 2 angle B's. in the first triangle, the angle B is different from the angle B in the second. So angle B is going to be congruent to angle C in the second. And then finally, we still have angle C. Different angle C is going to be congruent to, in the second triangle, angle B. Okay. And then we'd have our segments. Segment AB is congruent to segment DC. Segment BC is congruent to segment CB, reflexive property, that is the same side right here, just listed in different orders. And then finally, AC, segment AC would be congruent to segment DB. Okay, so one more example, and then we'll try to apply some algebra to congruent triangles. So here in this situation, I'm going to have triangle. Let's start over here, up at the top. Let's start at S, and we'll go from S to R to U. And let's think about what triangle that would have to be equal to. So by third angles, okay, we have these two angles are equal to each other. Our top angle, we started at S over here, so we'll start S here. Triangle S, and then we went R to U. We went along the single hash mark, so we'll go along a single hash mark, S to T, and then to U finally. Okay, so we have triangle SRU congruent to triangle STU. So they're not the exact same S, they're split in vertices, but we can, since these two sides are equal to each other, we know we have an angle bisector situation, so we would know that those angles are equal to each other. So we would just simply say that angle S is congruent to the other angle S. It's a different angle S. You have RSU and you have TSU, but we'll just call them both S. We'll be fine with that. And then we have angle R congruent to angle T. And then finally, angle U is going to be congruent to itself. And that's another segment bisector. So angle U is congruent to angle U in both of those situations. Okay. So our segments would be SR is congruent to ST. We can see that in the picture up there, SR and ST. We have RU would be congruent to TU. Okay. And then finally, we would have SU congruent to itself, SU. That this time we have the exact same segment. They share a side, so SU is congruent to itself. So finally, we'll try to apply some algebra here, and we have our congruent statement up at the top. They've already done that part for us. So if I want to solve for y, right, we start with y. It looks like this has two variables in it, so I'm going to hold off. I'm going to go and try to find y first, even though this says find the value of x. I'm going to leave that alone for a minute because it looks like I might need y. I can see, if I look at this, EF, right, EF has to match up with BC. So my equation would be that 2x plus y equals 90.6. They're equal to each other because their segments are congruent. Well, I can't solve that. So I'm going to come over here to D. Who does D match up with? D should match up with A. So this is going to be a solvable situation here. 2y minus 5 equals 65. We can solve that. I'm going to add 5 to both sides. So I have 2y equals 70, and then divide by 2. So y equals 35. Okay, so we do that first, and now we can go back and solve for x. So now instead of 2x plus y equals 90.6, we're going to say 2x plus 35 equals 90.6. That's going to be a little bit more solvable situation there. We subtract 35 from both sides, and that's 55.6. Obviously use our calculator for that. So I have 2x equals 55.6, and then I have to divide both sides by 2. So 55.6 divided by 2 is 27.8. So we get y is 35 and x is 27.